hope I'm recording the right tab. I need to record. I don't know if this is the right tab or not. We'll see if this works. What is the biggest screen for you all? Is my presentation the biggest screen, or is it my face? Or if you need to do, there we go. If you need to pin this to your screen, you can do that by just clicking the pin button. It's a presentation. All right, good. Awesome. That's exactly what I was hoping for. So hopefully this is recording correctly, and we'll find out, I guess. Maybe I'll never find out. I don't know. All right, I'm going to actually go to a full screen Google slide. Look how nice that is. Isn't that nice? Look how big it is. Interesting. Oh, I like this better. All right, anyway, compare viruses and bacteria. Now, we've been talking about viruses and bacteria a lot for the last week or so, and so hopefully we already know some of these things, but we're going to learn a little bit more today. All right, warm-up question. Based on what you've learned so far, what is one difference that you can think of between a virus and a bacteria? And for bonus points, one similarity, not really bonus points, just in your document, type in one difference and one similarity if you can. Also, copy and paste that to the chat log. I'd like to see what you guys are typing in. All right, Lindsay, I don't think I've kind of you present yet. I'm glad you're here, Lindsay. Joseph says, I'm here on my phone. Computer won't load meetings. Whoa, Joseph, you should call the tech people. Let's see. Austin says their size and they live inside of humans or animals. 2 says the difference. Viruses are genetic material. The RNA or DNA. Similarity of viruses and bacteria both invade and multiply within the host by evading the immune system. It's pretty good, Ram. Or 2, sorry, 2. Rihanna, both can get you really sick. Yeah. Charles, a virus can be bad and bacteria can be good in some cases. Yeah, all right. Unlike Corey says, unlike bacteria, viruses can't survive without a host. Yeah, viruses are not alive. Kind of creepy, to be honest. So that's one huge difference. Bacteria are living, viruses are non-living. All right, good. Let's move on. Your objective. Students would be able to compare and contrast viruses and bacteria. Our agenda, whole class. We'll do a warm-up and objective. We'll watch a video called Flu Attack. Do an activity called How Big? On your own. Hopefully we'll see how this works. Do the gem kits. Relax, like me talking more, you all doing fun things. Then we'll get back, a whole class. We'll do a thinking and a wrap-up. Oh, I can still do this, so that's cool. Nice. All right, difference between bacteria. Bacteria versus virus. So here's just some shapes. No notes to take here. It's just you can see different shapes. It's kind of blurry, to be honest. It's weird. Here is some of the structures of the viruses and the bacteria's difference. So it's a pretty cool picture. You can see the DNA in here. This one has a layer of proteins, and then it has an envelope around it, I guess you could call it, the lipid envelope. Some don't have that envelope. They're like naked. Seriously, that's what they call them. All right. Here's the difference in the sizes. Here's like a bacteria. This is supposed to be a pretty big virus, but look how small some of these viruses are all the way to the right here. Here's another picture with the size of the bacteria. So Grace and Ben, or Corey, sorry, you and Ben have been getting in and out a lot. You guys having technology issues? Yeah. So one thing you can do, let me show you. This is going to look weird for a minute. But one thing you can do. Oh, Myra, welcome. Um, so I'm down here by these three dots. You click on these three dots, this little thing comes up. You go to settings and go to video and change your resolution, the received resolution to standard definition. One of these two in the middle here. I think this one. Maybe even one video at a time. That might help you get better. Yeah, kind of like Centipede. It might be better resolution or better. Sorry, might not get kicked out as much. Yeah, so there's little hairs here. It's super creepy. That's E. coli bacteria, and I'm sure you guys have heard of that. It comes in like raw chicken. Mm-hmm. Yeah, look at the size difference between the red blood cell and the bacteria. And then here's the bacteria and the viruses. Tiny, 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 tiny. All right, let's keep moving. All right, active listener, answer these questions while watching the video. We'll see how this video goes. This four questions. What are the little knobby things that fit the lock called? What is the pink thing doing as the DNA goes in one side and the other? Question 3, one virus entered the cell. How many came out? And what color was the guy's shirt? That's me, so that's funny. Hope this works.
So let's say that this guy has the flu, could be any flu, and here's a droplet from his sneeze containing, if we move in and take a really close look, you see each one of those little purple things is a virus. And there are a lot of viruses floating through the air, some of which go inevitably up this unfortunate man's nose.
How did that guy feel when you ripped off half of his face?
It was interesting because we did it while he was sleeping.
Okay, I am talking with medical illustrator David Belinsky, who designed this video for Xirus, a research company. So here comes the virus, and it's going to land on one of this guy's throat cells. So notice it's covered with little yellow knobby things. You call these keys, right?
Those are the keys.
Yeah, this is a key, this is a key, this is a key.
Okay, if the keys on this virus happen to fit the locks, which are those little purpley stick-uppy things on the surface of the cell, if there is a match, the cell, watch this, welcomes the virus in. And what's this?
This is the welcoming committee. They all interlock with each other and they pull this membrane down into the cell.
And down it goes deeper and deeper, and that welcoming structure disperses, and the virus capsule bursts, and out comes the secret recipe for how to make more viruses in those little noodly things. So this unsuspecting cell has been tricked into guiding these virus recipes right into its own command center, the nucleus. So in they go.
And they are immediately recognized by this big pink molecule, which is a mini factory.
Yeah, what is it doing?
It threads the nuclear material, the instruction code of the virus, through one hole, and out another hole comes a brand new instruction set.
So it's a copying machine making copy after copy after copy of virus recipes, which then go out of the nucleus to little chefs, those blue peanutty things. They cook up proteins that go back into the nucleus where they are reassembled into baby viruses, and then out they go. They get covered up and head to the surface where they get new keys, and then boom, here they come. This is an eruption of virus after virus after virus after only one virus entered the cell. But how many came out? Well, millions. Millions. So if one virus can produce 1 million babies and do it again and again and again, how come this guy doesn't just drop dead, I don't know, in like 10 minutes?
Well, because you have about 100 trillion cells.
I see. So 1 million viruses is just a drop in the bucket when you have 100 trillion cells. And anyway, remember, you do have your own immune system, which when it sees a virus usually kills it. So while the virus does multiply fast, with any luck, your immune system will work just a little faster. So Yes, all viruses want to spread. That's what they do. But most of the time, we do keep them in check. Most of the time.
All right, cool. So there were a few questions. Hopefully you guys got them. What was the little knobby things that fit the lock called? You can type that into the thing or turn your audio on and say it. Keys, good. What is the pink thing doing as the DNA goes in one side and out the other? Making copies, good, Lal. One virus entered the cell, how many came out? Millions, 100 trillions, yeah, lots. I think it's millions. And what color was the guy's shirt that sneezed? Grayish black, yeah. Black, I think. Yeah, I'm not sure. It's grayish black. Let's see. I would say gray. Oops, it was gray. Yeah, yeah. Anyway, all right. How are we doing on time? So this next thing is a website called How Big. I don't know if we have time for all this stuff. Let's see. 56. Yeah, so right now you're supposed to be working on your own with something until 9:14. So I want you to go to the website. I think there's a link in your documents. Is there not a link? Oh no, there's no link, is there? Well, there's a link on the sheet, on the Google slide, I mean. So slide number 10, click on the link, and it's really actually kind of fun, this website is. So I want you to explore this website a little bit, and you can click on the different numbers, see how big things are. Click on the words up here. And then there's some questions to answer. Okay, so it says interact with the website and slide and answer the questions. Edit the drawing and drag these from smallest to largest. Do the first one for you. All right, so which of these is the smallest? Rhinovirus, human hair, Baker's Z. So you're gonna put them in order. Do that, you double click to edit, and then you literally just drag these to where you think they belong. So looking at the website, but you got to figure that out. Which is the smallest, which is the biggest, and they're obviously not in order. All right, so it is about 8:58 right now. 9:14 will reconvene, um, and hopefully you have these in order by the time we reconvene. So 9:14. All right, we're gonna start in just a minute here. I'm gonna put the answers up so you can check your work off of the answers. So the smallest on top, largest on the bottom. All right, it is 9:14. So I have the answer key up here. You can check your answers based off of that. We just got a couple more things to do. I want to get this Gimkit started ASAP so that we have enough time. I only have 10 minutes left in class. It's going to be like an 8-minute Gimkit. So hopefully, maybe it's going to be less than a 6-minute Gimkit. So I'm going to share the Gimkit screen, hopefully. Get it started soon. You'll go to gimkit.com/live. And then, oh, you know what though? I didn't set the time here. I have to cancel this one. All right, let's try again. All right, looks like I lost my screen. Uh-oh. Not presenting. There it is. Oh, no. I think it's working now. Joseph, the answers are in the slide. They're just hidden, so you have to open it up into its own tab. But we gotta get this started or else we'll run out of time. 78894. So it's on slide 12, Joseph, but it's just hidden. So you'll have to, click on the link at the top of your screen. And we're gonna get in as soon as we can at 9:17, maybe 9:18. We're gonna just get started. Yeah, Joe, good. And it's just a 5-minute Gimkit. That'll put us a couple minutes before class ends. As long as we start, we'll start at 9:17 exactly. I'll allow late joiners. So if you're still coming in, you joined up with a team. Either way. All right, it is 9:17. So if you haven't joined yet, join now. Hopefully this works. 30 seconds left. You will do it. Five seconds. Young, if you remind me on Friday during your quiz, after your quiz, I'll give you a bonus point. Or maybe Monday. Good job, Young. All right, awesome. So don't forget, Young. Second place, sorry. You guys did great, though. Claps. What are these claps? Claps. You guys will never hit 1,000 claps. No way. I said, Young, if you remind me on Friday after your quiz, I'll give you a bonus points. Bonus points. If you don't remind me, I will forget. All right, that's pretty much all we have time for today. Oh, you guys got 2,000. Well, that's cool. Pretty much all we have time for today. Make sure you get your assignment turned in. There is a wrap-up question, but it's really the same as the warm-up question. So if you don't get the wrap-up question done, that is okay. Just get this turned in. Turn in your assignments. All right, how many of you guys up to now? 2,500. What? No way. All right, make sure you get your assignment turned in. Turn it in. The bell's about to ring. Class is almost over. Turn your assignment in, and you can go. Good job today, people. Well done.